Welcome to the deep dive. Today, we're getting into something really relevant for anyone in tech. AI coding tools. What can they really do? And just as importantly, what can't they do yet?
Yeah, it's a hot topic.
We've got a couple of key resources guiding us. There's a pretty comprehensive AI coding capabilities report. Looks like it's from April 2025, so quite recent.
Right, that gives the broad picture.
And we're also looking at an article by Tom Smith discussing something called the SWE Lancer benchmark. Sounds like a real-world stress test for these AI tools.
Exactly, it puts them through their paces on actual tasks.
So our goal here is pretty simple. Cut through the noise, pull out the crucial info on capabilities, the downsides, what's coming next. Basically, get you up to speed without drowning you in technical details. Sound good?
Sounds great. Let's jump in.
Okay, first things first. When we say AI coding tools, what exactly are we talking about? Are they just fancy autocompletes?
No, they're quite a bit more than that now. Think of software that uses AI, specifically machine learning, to help developers across the board, the whole development lifecycle.
How do they work? Is it just pattern matching?
Well, yes and no. They learn from massive data sets of code, so they recognize patterns, but the goal is deeper understanding, context. They're trying to grasp the intent behind the code, aiming for real code intelligence across the entire project.
Okay. And the report highlights some key functions.
Yeah, the list is pretty extensive. Generating code, obviously, and finishing your lines.
Yeah.
That's code completion. But also finding bugs, helping refactor messy code. Security scanning is big.
And the natural language stuff, turning English into Python or whatever.
That's a major one. Plus, generating documentation, creating test cases, lots of different angles.
And who are the main players? I know GitHub Copilot is huge.
Definitely. Copilot's well known for suggestions and its chat feature, but there are others. Quoto is interesting, aiming for full stack support. OpenAI's Codex was foundational for that natural language part. Then you've got Replit, which is more like a whole AI-powered coding environment. Amazon Code Whisperer focuses on suggestions and security. Cursor AI builds AI right into the IDE. And others like Tab9, Ask Cody, Codium, FigStack, they each have their niche.
Okay, quite a few options. So moving beyond the features list, what's the actual impact? How are these tools changing software development day to day?
The biggest impact, I think, is on productivity. Plain and simple. Developers spend so much time on repetitive tasks, writing the same boilerplate code over and over.
Yeah, tell me about it.
AI can automate a lot of that. It frees developers to focus their brain power on the genuinely hard problems, the complex logic, the architecture, less routine, more innovation.
That makes a lot of sense. What about code quality? Does faster mean sloppier?
That's the worry, but actually, these tools can enhance code quality. Because they've seen so much code, they can suggest using established best practices, help maintain consistent style, spot potential bugs you might miss, and even suggest optimizations.
So it's like having a tireless pair programmer sometimes.
Kind of, yeah. A very knowledgeable one. They can also help manage technical debt by suggesting refactoring opportunities. And for learning, they're great. Instant documentation, examples right there in your editor.
So the benefits list is pretty long. Then speed, quality, fewer errors, better docs, security. It sounds transformative.
It really can be. When you look at code generation, for example, it's not just random snippets. Tools like SourceGraph Cody can look across multiple repositories for context. Replit's Ghostwriter analyzes code in real time.
And the natural language to code. That seems almost like magic.
It's getting there. Codex, Cursor AI, Ask Cody, they let you describe functionality in English. And like we mentioned, Quoto pushing for full stack generation is really ambitious.
What about keeping the code healthy? Debugging, optimization.
Right. Debugging assistance is a key area. Code Whisperer flags security issues. Codiga does static analysis. Snake focuses on bugs and vulnerabilities. Even Copilot's chat can help troubleshoot.
Like an AI safety net.
Exactly. And for refactoring or making code faster, Tab9 gives guidance. Codium has specific refactor tools. FigStack analyzes performance and even time complexity.
Time complexity analysis, wow.
Yeah. And test case generation, too. That's often tedious work. Kodo seems particularly strong there, aiming for full behavior coverage. Tools like Codium, Cody, Replit, Copilot Workspace, they're all getting into automated testing.
And documentation. Nobody likes writing docs.
True. Tools like Tab9, Code Whisperer, FigStack, Replit, they can generate doc strings, summaries, comments automatically. It makes it much less painful.
Okay, those are pretty core tasks. Are there other, maybe more advanced things these AIs can do?
Definitely. Code explanation is a really useful one. If you're looking at unfamiliar or complex code, tools like Quoto or Replit can explain it in plain English.
That could be incredibly helpful for onboarding or just understanding legacy code.
Absolutely. Then there's cross-language translation. Think migrating a project or working with diverse tech stacks. Tools like Code T5 and Code GX are working on that.
Potentially huge savings in effort there.
Right. For sure. And security, as we touched on, is becoming deeply integrated. SNCC uses AI for security analysis. Code Whisperer scans for vulnerabilities proactively. It's moving beyond just finding bugs to preventing them.
And code reviews, that's always a bottleneck.
AI is stepping in there too. Quoto Merge offers AI analysis for pull requests. Sorcery can automate reviews and CI/CD pipelines. CodeRabbit helps summarize changes and check best practices. It streamlines the whole collaboration aspect.
This all sounds incredibly powerful, almost too good to be true sometimes. Which brings us to the reality check. What are the limitations? Where do these tools fall short in the real world?
That's where the SWE Lancer benchmark from Tom Smith's article is really insightful. They didn't just test small snippets. They used actual freelance tasks from Upwork. Real-world complexity.
Okay, practical tests. And how did the AI do? Did it live up to the hype?
Not entirely. Its dose of realism. Even the top models, like Claude 3.5 Sonnet at the time, only managed to successfully complete about 26% of the individual coding tasks. GPT-4 was even lower on those.
26%. That's not amazing for the best model.
It shows there's a gap, right?
Yeah.
Between controlled demos and messy, real-world problems.
So what were the main sticking points? Why did they fail?
The benchmark highlighted a few things. The AI often tackled the problem at a surface level, missing deeper context, especially across multiple files or system components.
Ah, the context problem again.
Exactly. Their ability to test their own solutions was often poor. They generated code but didn't adequately verify it, and they really struggled with edge cases, those tricky, less common scenarios.
But it wasn't all bad news, was it? Were there any positive signs?
Oh, definitely. The AI was actually very fast at locating specific files or functions in a large code base, sometimes faster than humans.
Interesting.
And they perform better when asked to evaluate or choose between code solutions compared to generating code from scratch. Also, giving them more time and allowing multiple attempts significantly boosted success rates for some models.
So persistence pays off, even for AI. What was the main takeaway from Tom Smith then?
His core point was clear. AI is a programming assistant, a powerful one, but not a replacement. Human skills, especially around testing, quality assurance, and understanding the big picture, are still absolutely crucial.
The human oversight part.
Precisely. He also speculated that maybe management roles involving code evaluation might see AI impact sooner than hands-on development. But ultimately, the engineers who learn to collaborate with AI are the ones who will thrive.
Assistant, not replacement. That seems key. But there are other concerns too, right? Beyond just task completion rates, what about code quality overall?
Yeah, that's a valid concern. The SWE Lancer results showed AI sometimes introduces subtle bugs. And there was another study, I think, from GetClear suggesting AI use might correlate with more duplicated code, less refactoring, maybe leading to technical debt down the line, if not managed well.
So you get speed, but potentially at the cost of long-term maintainability if you're not careful.
That's the risk. It underscores the need for human review and validation. Over-reliance is another danger. Developers might lose some problem-solving sharpness if they just accept AI suggestions without thinking critically.
And consistency. Do they always work?
No. Performance can be inconsistent. They can still hallucinate or fail unexpectedly on tasks that seem straightforward. Security vulnerabilities can also creep in if the AI isn't trained or prompted carefully, and there's definitely a learning curve to using these tools effectively.
Okay, so a lot to consider there. Given the sheer number of tools, how should someone approach choosing one? We mentioned categories earlier.
Right, thinking in categories helps. You have those agentic assistants like Aider, Cursor, Quoto. They try to handle more complex, multi-step requests, almost like a junior developer you can delegate to.
Okay.
Then the code completion and assistance tools, Copilot, Tab9, Code Whisperer, focused on speeding up the moment-to-moment coding with suggestions.
The classic autocomplete on steroids.
Sort of, yeah. And then specialized tools, SNCC for security, Quoto Merge for code review, Code T5 for translation, tools focused on one specific part of the workflow.
Got it. So when you're picking, what matters most?
Well, first, does it fit your workflow? Does it support your languages and frameworks? How steep is the learning curve? What's the cost versus the benefit you expect?
Practical stuff.
Yeah. And community support, documentation, security features are important too. Does it help with team collaboration? Does it actually solve your specific pain points? And crucially, how does it perform in real tests? Like SW Lancer hints at, maybe run a small pilot project first.
Good advice. And once you have a tool, how do you get the best results? Just turn it on and hope for the best.
Probably not. Prompt engineering is key. Learning how to ask the AI clear, specific questions, breaking down big tasks.
Giving it good instructions.
Exactly. And giving it context, having the right files open, using good comments. Then iterate. Don't just take the first answer. Validate it. Give feedback. Maybe rephrase your request.
Treat it like a dialogue.
Yes. And always combine AI suggestions with your own judgment. Humans are still essential for testing, architecture, catching subtle issues. Learn the tool's specific features, like quote merge commands or ADER's file management. Use collaboration features if you're in a team. And stay updated. This field moves fast.
It really does. So, looking ahead, wrapping things up, what's the big picture? Where is AI in coding heading?
I think the overwhelming direction is augmentation. Supporting developers, making them more productive, maybe significantly more, like some studies suggest, but not replacing them wholesale. The SWE Lancer results really back that up for now.
But quality assurance becomes even more critical.
Absolutely. If AI generates more code faster, the burden shifts even more towards robust testing and review.
Yeah.
We see tools emerging specifically for AI-assisted QA, like CodoGen or Codium AI, but human expertise remains vital.
And the industry impact. Faster development, maybe.
Likely faster delivery, yeah. Maybe enabling more complex projects. The market for these tools will definitely grow. AI proficiency becomes a core skill. We might see shifts in roles, like Tom Smith suggested, but it's still augmentation driving value, not just replacement cost-cutting. And the tech itself keeps evolving, constantly. Better LLMs like GPT-4o, Claude 3.7, new open-source models, more specialization in tools, deeper integration into IDEs like Cursor, more agentic AI. It's a really dynamic space. Seamless integration is the goal.
So the future is developers working with AI, leveraging its strengths while covering its weaknesses.
That seems to be the most realistic and, frankly, the most productive path forward. Recognize it as a powerful assistant, use it strategically, but keep the human firmly in the loop for critical thinking and quality control.
This podcast was generated from our AI Coding Capabilities report, available in the Valuable AI Report section on AgentFarm.ai. Thank you for joining us today. We're here to share insights and ideas. Your support means everything. If today's discussion sparked an idea or helped you, let us know. Drop us a line, leave a review, and visit AgentFarm.com for more tools and insights. Until next time, stay inspired.